Find the greatest 4-digit number which is a perfect square. To find this 4-digit number which is a perfect square, first check whether the greatest 4-digit number is a perfect square or not. The greatest 4-digit number is 9999. First, let's check whether this number is a square number or not. We'll use long division method. So first make the pair. Now 9 times 9 is 81. Subtract here, you get 18. Then write this 9 here. 2 times 9 is 18 in the blank space here. Now let's check what digit can we put here. So for this you should know what is long division method, and if you haven't watched the video tutorial on this, please watch that first so that you can understand what we are doing here. So this is 18. Let's put 8 here. So you get 8 times 8 is 64, and 8 times 8 is 64, 77, and 1504. Here you have 189. You get 9 times 9 is 81, and 8, 9, 8, 72, and 88. This is 1701. So you'll take 9 here, and you get 1701. Now when you subtract it, you get 198, right? 190, yeah, you get 198. It means that this number 9999 is not a perfect square. So what can we do to this number so that we get a perfect square? That is a 4-digit number. Clearly, you subtract this 198 from this 9999, subtract 198 from it, and you'll get a perfect square, because this remainder tells you that this number 9999 is greater than 99 squared by 198. Clearly, this remainder tells us that this 9999 is greater than 99 squared by 198. So if we subtract from this 9999 this number 198, you'll get the number you'll get will be actually equal to 99 squared, because in that case now you'll get this remainder 0, right? So do this. If you subtract from this one 198, so you get 108 and 9801. So this 9801 is the 4-digit number which is a perfect square, because this 9801 is actually equal to now 99 squared. Okay. Find the number of digits in the square root of each of the following square numbers without any calculation. We have some numbers here. This is 2-digit number, this is 4-digit number, this is 5-digit number, and here you have 6-digit number. You don't have to do any calculation, and without calculation you have to tell the number of digits in the square root of each of these square numbers. So we know that if your number is having even number of digits, if your number has even number of digits, then the square root of that square number, if your square number has even number of digits, then the square root of that square number will have n by 2 digits. We have discussed this one, right? You can find the tutorial in the playlist. I'll put the video link in the description box below. Now, if your square number has odd number of digits, then the number of digits in the square root will be n plus 1 by 2 digits. Okay, so if you take for this first one, how many digits do we have? 2. That is, n is equal to 2 here. So if n is equal to 2, then 2 by 2 is what? 1. Let's take this one. How many digits do we have? We have 4. That means n is equal to 4. So n by 2 means what? N by 2 means 4 by 2, and it is equal to 2. That is, your square root will have 2 digits. In this case, you'll have 1 digits. Right. Now, in this case, we have 1, 2, 3, 4, and 5 digits in this square number. So its square root will have, since n is equal to 5, therefore square root will have n plus 1 by 2 digits, that is 5 plus 1 by 2 digits, that is 6 by 2 digits, that is 3 digits. And then this last one, you have n is equal to 6, that is, you have 6 digits, therefore the square root will have n by 2 digits, that is 3, right? Okay. Find the least number which must be subtracted from each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtained. Okay, it's quite similar to what we have discussed here. So your first number is 3250. Your first number is 3250. This 3250 is not a perfect square. You have to subtract certain number from this number so that your resultant number is a perfect square. Let's do this. If you use the long division method to check the remainder, right? The remainder is a game. So start making pairs. Here you'll put 5. So 5 times 5 is 25. You subtract it, you get 7. Now write 50 here. 2 times 5 is 10. Okay. Now this is 10 and this is 750, a blank space here. So what digit should we put here? If you do here 7, yeah, take here 7. So if you do this, you get 7 times 7 is 49 and 4. So you get 749. So here you'll put 7. You get 749. When you subtract it, you get 1 as the remainder. It means that this 3250 is greater than 57 squared, is 57 squared by 1. The long division method, in long division method, 57 is actually tells what? It tells about the square root. If you get the remainder 0, then the quotient tells you the square root, right? But in this case, clearly this 1 tells you that this number is greater than 57 squared by 1. So if we subtract 1 from this number, that is, if you subtract 1 from this number, you get 3249, right? It becomes 3249. In that case, here you get what? You get 49. In that case, this 50 is not 50 but 749. So now clearly you'll get this remainder as 0, right? So this becomes what? 57 squared in that case. When you subtract 1 from this 3250, your resultant number is 3249, and the quotient tells us what? The quotient tells us the square root. That is a definition of long division method. That's quotient tells us the square root. It means that your resultant number is 3249, and you get this number by subtracting 1 from 3250, and the square root of 3249 is 57. Right. Let's take this 1989. So this is 1989. This is not a square number. Again, let's check for the remainder. So we pair it. Now, clearly this is 4 times 4, 4 squared. So this becomes 16 minus, you get here 13. Sorry, we get 3. I'm sorry, we get 3. And we write 8, 9 here. Now 2 times 4 is 8, right? 2 times 4 is 8. If we put this blank space here and if we have to check it, what can we get here? 8 times 3 is, or we can take 8 times 4. 8 times 4 is 16 and this becomes 336. So 8 times 4, you get 336. Okay, in this case, you get the remainder of 49 and 53. Okay, it means what? It means that this 1989 is greater than 44 squared by this 53, by this much value. So if we subtract 53 from this one, what do you get? 9 minus 3 is 6, 8 minus 5 is 3, you get 1936. So if you subtract 53, then here you get what? 36. So in that case, here you get 36, and when it goes 4 times, so you get finally remainder as 0, right? So for 1936 is that number which you get after subtracting 53 from 1989. 1936 is now a square number whose square root is 44, right? Okay. Find the least number which must be added to each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtained. Now this is similar to this one what we have discussed here. In this case, it's reverse of what we do here. Here we subtract, but here you have to do addition. Okay, so 1750. Take this one, 1750. Okay, again the whole game is of remainder. Let's pair it. Now here you get 4 times 4 is 16. You get 1 here and 5, 0. 2 times 4 is 8. 2 times 4 is 8. Let's put blank space here. So what can we take here? 8 times, if we take, you can go only one time. So here you will have 81 here and 1 here. So you get 81 here. Now subtract it. So when you subtract it, you get 10 times minus 1 is 9 and 14 minus 8 is 69. Okay, so this is 69. Now clearly it tells us that in this case, remember, you have to add, right? You have to add in this case. So since the quotient always tells us that this 41 tells us that what will be the square root, right? It means in this case 41 squared is less than 1750, right? That is clear. 1750, 41 squared is less than 1750 by 69. This much is clear. Okay, but in this case we cannot subtract. If it was asked to subtract, then we would subtract by 1750 this 69 from this one, but we don't have to subtract. In this case you have to add. So think that 41 squared is less than 1750 by this much, but if we take 42 squared, in this case if you take 42 squared, right, that means if you multiply here 2 and then put 2 here, in that case this will exceed, right? And that is why we didn't take 2 here. It means 1750 will be less than 42 squared, and here we get the answer. And how? So if you find this 42 squared, you get 4 to 8 and 16. You have 4, 16, 7 and 1764. So this 42 squared is 1764. It means that if we add 1764 minus 1750, you get 4 and 14. It means that if you add 14 to 1715, you get 1764. In that case, that is equal to 42 squared, right? Because in this case you have to add. Add means that your final number will be greater than this one. When you subtract, then your square number is actually smaller than the previous one, that it was initial one given to you. In this case it will be greater than. Now what's this number? The number is 1764, and in this case what will be the square root? Square root will be 42, because 42 squared is 1764. It means that when you have to take the square root will be 42, right? Now let's find out this 6412. In this case we have 6412. Let's do the pairing. And now the long division method. Now in this case here it goes 8 times 8, that is 8 squared is 64. Subtract, you get 0 here. Now you have 1 and 2 here. 2 times 8 is 16. 2 times 8 is 16. Blank space here. It means that clearly you have 12 here. Here you have 16, and then you have to put a digit here. It means that you'll go 0 times, right? So you get 0. Subtract, you get 12. Okay. Remainder is 12. It tells us that 80 squared, because this number tells us, in the quotient tells us the square root, about the square root. This is not a square number because we are getting a remainder. It means that this number is actually greater by 12. It's greater than 80 by 12, right? 80 squared. So 80 squared is actually less than 6412 by 12. But this 6412 will be less than 81 squared. Imagine that if you would have, if we would have taken here 1, right, then at the place of 80 you will not get 1 but you will get 81, right? That's why. So this is 6412 will be less than 81 squared. It means that if you find 81 squared, you get 1761 in this case. 81 squared is 176, sorry, 1 times 1 is 8, 8 and 8, 64, I'm sorry. It was my mistake. 818 and 88, 64. So you get 1 here, you get 16 and 5 and 6561. It means that if you find this difference between these two, you get 9, 5 minus 1 is 4, 1. This is it. So you get 149. It means that if you add 149 to this number, if you add 149 to this number, that is the initial one, you get 9 times 2 is 11, 4, 1, 5, 6, and then 5, and you get 6561. That is exactly equal to this one. That is equal to 81 squared, right? So if you add 149 to this number, that is 6412, then you get 6561. That is square number now in this case. And what's the square root? Since 81 squared is equal to 6561, it means that square root will be 81 in this case.